Let f is a function from r square to r defined by f of x by this structure. Then the value of this one at the point 0, 0. This is partial or second partial derivative of f with respect to x and y plus second partial derivative of f with respect to y and x. So what is the meaning of these partial derivatives, second partial derivative at a point 0, 0? So f of xy, its simple meaning at 0, 0 is partial derivative of fy with respect to x. You can understand this by as written. So this one equal to limit h tends to 0 because of we are doing partial derivative with respect to x, so normally we take h for x. Fy, this is function 0 plus h comma 0. These are points, as you can understand, a plus h comma b if we are doing partial derivative at point ab. So we can write like this: minus f of h comma fy 0 comma 0 divided by h. To find this expression or limit, first we need to calculate this expression and this expression. We have two expression to find this partial derivative with respect to x of fy. So first calculate this one. So this is limit h tends to 0. This is nothing but fy h comma 0 minus fy 0 comma 0 divided by h. This is simplified form of above one. So f of h comma 0 is nothing but limit h tends to 0 or you can find here fy0 fy h comma 0. So call this is a equation 1 or this is principal equation. So fy h comma 0 means partial derivative of f with respect to y. So partial derivative of f with respect to y at the point h comma 0. This is the simplest meaning of this. So write f of h comma 0 plus k, limit k tends to 0, because we are finding partial derivative with respect to y. So normally when we take partial derivative with respect to y, normally we take k, as it is usual, many mathematicians used. And this is f of h comma 0, this at a point value of the function divided by k. And this is nothing but limit k tends to 0 f of h comma k minus f of h comma 0 divided by k, as hk are tending to 0. These are not equal to 0, exact not. So value of this one will be x y square divided by x plus y, means first defining process will give the value of this one. So put limit k tends to 0 and f of h comma k will be hk square divided by h plus k minus f of h comma 0 will be 0. If you put in place of second element 0, then entire expression will be 0 divided by k, and this is nothing but limit k tends to 0, hk square divided by h plus k, and outside you can write k, and k cancel out by this. So limit k tends to 0, hk divided by h plus k, this is form. And after taking the limit as k tends to 0, k tends to 0, so 0 upon something will be 0, so limit of this one is 0, means simply we can write fy at 0 comma h is 0. We will put this value in principal equation 1. Now second one was we have to find fy at 0 0, which is used in equation 1, will be limit, because we are finding partial derivative with respect to y. So again take k tends to 0, f of 0 and 0 plus k minus f of 0 0 divided by k, and this is limit k tends to 0, f of 0 comma k minus f of 0 0 divided by k. F 0 0 is 0, and value of first coordinate is 0. So if you will put in this expression, then because function is defining like that, x y square divided by x plus y, if one coordinate is 0, by numerator terms it will give you value 0, so 0 upon k equal to 0. So fy at 0 0 is 0, call this is equation third. So use equation 1, therefore f xy at 0 0 is equal to limit h tends to 0, and what we have done here, as you can see, this is equation 1, value of first expression, this expression is nothing but 0, and value of this expression is again 0, so 0 minus 0 divided by h, so we obtain 0 minus 0 divided by h, and this is equal to 0. So f of xy 0 0 is 0. Now asked about f of yx, fyx at 0 0. Same process here we have to find, because we are going to find the value of del 2f upon del x del y plus, sorry, partial x partial y plus partial second partial of f over partial y and partial x. Now calculate this one. So meaning of this is, you can understand partial derivative of f with respect to y, partial derivative of fx with respect to y, this is the meaning. So you can write limit, because of with respect to y, k tends to 0, simply write k tends to 0, and function is fx, so fx 0 comma 0 plus k, because point is 0 0, minus fx at 0 0 divided by k, and this is limit k tends to 0, fx 0 comma k minus fx 0 0 divided by k. Call this is second principal equation, so call it Q. And as we find earlier, we have to find this one expression and this one. First, fx at 0 comma k will be limit h tends to 0, because we are going to find with respect to x f of 0 plus h min comma k, 0 plus h comma k, because point is 0 comma k, minus f of 0 comma k divided by h, and this is limit h tends to 0 f of h comma k minus f of 0 comma k divided by h. This will go to 0 by the defining way of the function f of xy. One coordinate is 0, because function is defined as xy square divided by x plus y. If one coordinate is 0, in place of x is 0, then entire will be 0. So it will be hk square divided by h plus k, and you can write h outside denominator, so h cancel out by this one. So left one is k square, and limit is running h tends to 0 k square divided by h plus k. If h tends to 0, then this limit will be k square upon k, and this is equal to k. Similarly, we have to find fx at 0 0, and this one equal to limit h tends to 0 f of h comma 0, or 0 plus h you can write, minus f of 0 0 function at the point divided by h. Both coordinates are 0, so this term will go to 0, and this one again go to 0 by the defining structure of function. So limit is 0. Now put all these value in equation q. So equation q implies f of yx at 0 0 will equal to k minus 0 divided by k, and k by k is 1. So finally asked about this one as partial. So we have find means f of xy plus f of yx, and both this value was 0, and this one we have calculated in last as 1. So 0 plus 1 is 1. So at the point 0 0, this value is 1, so option B is correct.